For those that are here, I'd like to welcome you all to the webinar, the Automation Tips webinar on getting started with code-free programming in the cloud. I'd like to thank you guys that have attended for taking time out of your day showing up for this. Just a quick note that the session will be recorded, so you can actually just watch and participate, and the recording will be sent out afterwards. So my name is Jeremy Andrews, and I am essentially the user education specialist over here at Vention. And my role is to onboard and educate users on Vention's platform and all that entails. So with that, I'll actually go over directly to the agenda for everything that will be covered throughout the webinar. So for the webinar, there will be four main things that I'd like to cover throughout the session. The first being how to configure your Vention machine directly in the cloud on your web browser. Second, do an iteration of essentially Vention's hello world, so everyone's first program when they get started with programming, to show you how easy it is to do a simple programming with Vention's automation system. Third, to be able to create a fully functional automation sequence. And finally, to actually simulate design directly within your browser live. So throughout the session, there will be a few different ways you can actually interact. First is that you can ask questions in the Q&A section in the Zoom platform. Second, you can actually chat with the participants as well as myself and my colleague who's on the line, Rowan, will be moderating the section. And finally, at the end of the webinar, there will be an open mic session portion where you can ask questions, both myself and other participants as well. So without further ado, I'll actually jump right into it and go off to the first portion, which is configuring your machine. The first thing that I like to actually do before going to the configuration page is, for those that are new to Vention's platform a little bit, is to talk about what a MachineLogic is. So MachineLogic is the program that I will be using to create these automation sequences. At its core, MachineLogic is a code-free programming and simulation tool that's designed for industrial automation. And the greatest thing about it is it's available directly within your browser. You don't have to download or do anything like that. If you want to learn more about this, we do have this page that you see on screen over here, the MachineLogic page that you can find on our website that does go into a little bit more depth about what you can do with it. With that, I'm actually going to switch over to a design to get started with the configuration. So once you do open a MachineLogic machine builder design, this is what you'll see on screen over here. The first thing that you'll notice is the top of the screen, there are three separate tabs. So on the left, you have machine scope, which is really where you organize your design. Machine builder is where you actually assemble and build your design. And finally, the MachineLogic tab, where you can program your automation sequences. If I hover over it on the right, you'll notice that it does prompt me to add a machine motion controller to use MachineLogic. So what I'll be doing is I'll be adding machine motion controller, but to actually showcase some of its usability, I'll be adding a linear actuator with it as well. So on the left over here, you can go to the linear motion category and select a enclosed timing belt actuator. Again, so what I'm doing, I'll be kind of going through everything and saying what I'll be doing. And if you have any questions, feel free to raise your hand or ask them in the chat section. So I'll drop this on screen over here. On the left over here, we have the configuration assistant that does automatically pop up if you had it set to it. So what it does, it essentially adds all of the automation equipment required to create a fully functional linear actuator system. Or if you're using, say, a belt conveyor or pneumatics, it does add the required hardware. So in my case, I'll click autocomplete, and it will then prompt me to add the machine motion controller and an ESOP for safety. So you'll notice once I do add it to the design, it does showcase that I can use the MachineLogic programming. Click done, and you'll see that the MachineLogic tab is now accessible. So I'll actually open this up here and go to the configuration. Recenter the design to give you guys a little bit better view of what's going on. And over here, so over here, this is the MachineLogic tab that you'll be seeing once you open it up yourself. So we do have quite a few windows over here that do walk you through some of the basic steps, but I'll be doing this with you as well. So the first thing that you can do to actually start with configuration is add the actuator that you plan on using. So in the bottom left corner of your screen, you have the option to add actuator. So that's what we'll do right now. So clicking that, you'll notice that it does populate the screen with the drive one, as well as a drop-down menu with a type of actuator that you can then select from. You can actually continue to click add actuator. And one thing to note is that we try to mimic real life as closely as possible. So in my design over here, if I scroll over to my machine motion and look at the bottom, you'll notice that there are 4 different drive ports. So the drive ports allow you to power one motor at a time. So if I recenter my design and go over here and click on add actuator, I can add up to 4 different drives by clicking it over and over. So drive 1, 2, 3, and 4. If I do try to add an additional drive by clicking add actuator, you'll notice that it will default to pneumatic. The reason being is that we only have 4 ports, so you can actually drive another actuator. If I do add another machine motion controller, I should be able to then add more. But for the purpose of this, to showcase how easy it is to configure, I'm actually going to delete these over here and go back to just one. So to configure my actuator, I have the enclosed timing belt over here. So what I do is I go from the drop-down menu under Type and select the enclosed timing belt. Later on, I'll showcase how easy it is to do this with multiple actuators in your design. But in this one, since I only have the enclosed timing belt, it only gives me the one option over here. So I'll select this over here, and this is the configuration section. So you'll notice that some of the fields are already pre-filled, such as the motor size, the homing sensor, and end stop sensor. The way this works is the design is automatically scanned when you add or select your actuator to see what hardware is connected to it. So on the left over here, if I highlight the homing sensor, you'll see on screen behind the motor, there's a slight green outline around the homing sensor. On the right, if I go to the end stop, you'll see it's highlighted in green. And finally, the motor size is highlighted. If I did have a smaller motor, it would default to that one as well. Say I were to go over here and delete the motor, it prompts me to refresh it, and you'll notice that the motor is no longer there. I'll undo that action, refresh, and I'll bring it back. The final thing to note over here in this basic menu is you do have a tick box for brake and gearbox. If I had one of those installed in this design, it would automatically tick off one of the boxes that you will see a little bit later on in the webinar. The final thing is the advanced menu. So drop down over here, you do have the option to change the custom current or the tuning profile of your actuator. However, I'd recommend leaving them as is, since this is defaulted to the type of motor that you have selected. So again, if I go to a slightly larger or a slightly smaller motor, the custom current and the tuning profile will change accordingly as well. The final thing to note is in the bottom over here, the other options that you can add. So you'll notice is after I added the add actuator, the add robot did get grayed out. So one of the reasons is that you can actually add one of each in your design, but you can only configure one at a time. So in a later webinar, we actually will be going over how to configure and program a robot. So if you are interested in that, I will invite you to that later on. Other options are the ability to add an input as well as an output, but again, these are a bit more advanced that won't be covered today. So from here, we'll actually be going over to the visual sequence tab, where we actually will start the second portion of the webinar, which is creating our Vention's version of Hello World, or your very simple first program. So once you have configured, you go over to the visual sequence tab. I'll give you a bit more information over here. So over here it says to click Add Applications to start creating your first program. So we'll do what it says and go in the bottom left corner and click on Add Application. So add a custom application essentially is adding a new program that you plan on building. You notice that I can actually add quite a few, and each of these essentially act as single individual programs that you can then use to program your automation device on the right side. For us, since we're doing something simple, I'll delete the other two that I created. So we just have the one over here. So now I'll go over the information that we have on the left before programming it itself. So if you go over to the variable section, you can actually rename it. In our case, I'll be naming this webinar test, and you can confirm by pressing enter or clicking elsewhere on the screen. Also over here in the variable section, you do have the ability to add variables, both as a standard numeric variable or as an input variable. Again, these things are a bit more complicated and won't be covered in today's session, but if you do have questions on them, you can ask them later or in an email as well. Afterward, down here on the left, we have these sequences. So we both have main sequence and the child sequence. So the main sequence itself is the entry point of your program. We actually build and assemble it. And the child sequences are the functions that are called within your main sequence. So essentially the sub-functions used to create your program. Again, for now, child sequences will be covered a little bit later on today. So I'll delete that and go straight to the main sequence. So right now, I'm going to build my first program with you guys. The first thing that I'm going to do is, the program that I would like to build is have the actuator move the gantry plate, which is this plate over here on top of the actuator, to its home position, so all the way to the left, move it all the way to the end, and then back to the center. So it'll be a combination of 3 different moves. So I'll go to my add command over here in the bottom left corner and select the type of command I would like to do. Notice there are a few different options. So you have the option to add a motion, which is what we'll be doing, add a weight, which is pretty self-explanatory, but will be covered a little bit later, output, execution, variable, and etc. Some of these, again, will be covered today, some in the later sessions when we go into some designing more complicated automation systems. So for us, we want to build a program that has 3 different move commands. So I'll add 3 different motion commands, 1, 2, and 3. Notice as I go through this, I'm not actually writing a single line of code. I'm really just using the click and click interface designed for MachineLogic. So it's really easy and intuitive to use. So this, the one thing that I'll actually do is rename the actuator. So you'll notice over here, I have the actuator drop-down menu. So from here, this is where you select the type of actuator that you would like to have it move or accomplish the action on. So I'll go back to my configuration page over here and rename this one timing belt. With that, you'll notice if I go back to my visual sequence, it actually automatically changes it as well. So if you do have commands that are referencing a specific actuator, you can go back to the original name, change it, and it won't affect your program whatsoever. So in this case, I want to first move to home. So I've already selected the timing belt, which is the actuator I'd like to move. Then from here, I'll select the type of motion. So in the drop-down menu, I have moved relative, to position, and to home. The other two I'll touch on a little bit later, but for the moment, I'll select to home. You'll notice it will take away the distance/variable window on the right, since move to home is an absolute motion. It really just goes to a fixed position, and that's it. After this, I'd like to do two other move commands. The first, sending the actuator all the way to the opposite end. So with that, I'll do the move to position. First, I'll highlight what move relative is. Move relative essentially moves the gantry plate. So again, the plate on top of the actuator over here to a position relative to where it currently is. Move to position moves to an absolute position along its available travel. So in my case, I'm going to move to position, and select a value of about 575, since the available travel over here is about 580. With that, I'll go to the second one, move to position, and have this move about halfway. So let's go to 250 millimeters. So that I've actually completed my first program. It's as easy as that. There's no need to do any extra validation, compiling, or anything like that. You simply put in the commands you'd like to do and press play to run it. So we'll go over to the bottom over here and press play to actually simulate this in real time. By pressing play, it will then highlight the command that is being shown on screen and run through them. So since this was a very short program, it did go through it relatively quickly. So I'll press play once more. You'll see that it'll highlight the home as it moves to the left, highlight the middle action as it moves all the way to the right, and move to the middle, the final one. One of the great things about this program is it's very easy to reorganize and change your program as well. Say, for example, I actually wanted to move to the center first before moving all the way to the end. I don't actually have to delete my commands, bring in new ones, choose the type of motion I want, edit the variable again. It's as easy as actually dragging and dropping the commands to reorder them in the orientation that you'd like. So in this case, I have my move to home first, and with that, I can actually drag and drop my commands to the appropriate position. So now if I press play again, my gantry plate will move to the left, its home position, move to the center of 250 millimeters, and then move all the way to the end. And that's how easy it is to create a very simple automation sequence. So from here, I'll actually be changing over to a more complete design and refresh this over here to showcase how easy it is to translate this basic setup over here to something a bit more complicated. So I'll close that tab over here, bring this up over here. So the design that I'll be using over here is essentially a 2-axis pick and place machine with an in-feed conveyor. So essentially at its core, a 2-axis pick and place machine, what it's meant to do is pick up an object in one location and drop it off in another. The conveyor that you will be seeing on screen momentarily, its main purpose is essentially bring a box to the picking location for this application. So I'll zoom in over here and just go over what I just mentioned. So we have a 2-axis machine with an enclosed ball screw as the Z-axis, an enclosed timing belt as the X-axis, and then a conveyor that does bring in the cardboard boxes as the in-feed system. Again, I have the machine motion controller over here, and double checking, you'll notice that I do have the 4-drive port to run the 3 different drives that I have on screen. So if I recenter, you notice I have the 1 drive at the top of the enclosed ball screw, the second one at the end of the enclosed timing belt, and the third one over here at the end of the conveyor. So with this, I'll go back to the MachineLogic. It's already opened up since I do have the machine motion controller in my design, and then go through the exact same steps that I went through in the basic 1-axis system. So in this case, since I have 3 actuators, I can go ahead and add 3 actuators right away. And here you'll see a bit more. It does have a larger drop-down menu. In this case, I want to first program my enclosed ball screw, which will be my Z-axis. So I can select this one over here. And the major difference over here is you'll notice the brake is installed on the design right here. So it does have it ticked off. You don't have the option to change this since this really is meant for a pure safety system. So in this case, I can change the actuator name right away to Z-axis. Zoom out, and then use the second one, which will be the enclosed timing belt. This one I'll name x-axis. Again, all of the other information is pre-configured, but I can go over it just to double check. Again, using the home end sensor is the one on the left, and stop is the one on the right, which is what I am looking for. And the final actuator that I'll be using is the conveyor. And then I can rename this one properly as well, conveyor. The one thing that you notice for the conveyor is that it does not have a homing or end stop sensor, since it is a continuous motion device and does not require one to move. However, one can be added if you would like to add some additional functionality to your design in the future. So this, we can actually go over to the visual sequence section and show how easy it is to create a more complex automation sequence. So again, I'll follow the exact same steps to showcase that it does translate from a very simple system to something more complex. So I'll be creating one application or one program, going over to the variables and rename it aptly. So in this case, I'm gonna name it pick and place, since that is the action that I would like to accomplish with my system. With this, I won't be adding any variables for the moment since I don't need them right away, but I will be going over to the sequences. So here is where the child sequences will come into play. So child sequences are really important when you want to create a more streamlined program that is easier to read and build later on. So you can build the entire program within the main sequence, but if you want to do any individual edits, it is recommended to create child sequences or smaller functions, as it will be easier to change later on. So in my case, I'll be adding two different child sequences. The first being a home sequence, like we saw earlier, and the second being the actual pick and place application sequence. So I'll go down here and select add sequence twice and rename them to the ones that I just described. First one will be home, and the second one will be pick and place. Again, you can name it the same as your entire program or your application, or name it something else if you really would like to. So we'll start off with the homing sequence over here. So on our system over here, we have two actuators that we'd like to home, both the X and the Z axis itself. The conveyor does not require homing, since like I said, it is a continuous motion device. So I'll go to add command and add two separate motion commands. So I do have the option then to select the Z axis, the X axis, or the conveyor. And there is one more action that I will showcase right afterwards. But in this case, I'll first home the Z axis to get it up and out of the way, since that usually is recommended and is the safest move for pick and place applications. So I'll move the Z axis to home, move the X axis to home, and this will, I'll add two more motion commands and touch on the all actuators that I did show earlier. So all actuators, if I change them both, does give me two more options in the motion drop-down menu. The first is to be able to set the system speed, and the second to set the system acceleration. In this case, I'll set the system speed as 1500 millimeters per second, and the acceleration at 1000 millimeters per second. For right now, this really is just used for demonstration purposes, so the system will run faster once I do simulate, but it is recommended to actually check with the type of actuator they're using to make sure that the acceleration and speed match the available actuators that you've chosen. Some do run at a slower acceleration, so I would recommend double checking with that as well. So with that, we've then set the acceleration, the speed, and the move to home. So with this, we can go to the pick and place portion and actually build out our program as well. So for pick and place, really what I would like to do is I'll change to a side view over here to go through or walk through what I would like to build. So once my application or once my actuators are homed, they'll most likely be in the top left corner. So I have to get my actuator over to the right side, bring it down to pick up the box, bring it back up to the left, and then back down to drop it off. So build the sequence in that order. So we'll start off by adding a command, starting with a motion command. Again, I already have the Z-axis all the way up, so I'm going to get my X-axis over to the right side. So there are a few different ways to do this. First, if you know exactly where you would like to have the actuator move, you can simply input the position or variable right away. In my case, say I don't know exactly where I'd like to move it, I can actually teach the position. And what that means is I can actually move the actuator over within my CAD system to the specific location that I'm looking to have it move to, and press teach position, and it'll actually record it there in the variable section. So this is great in that when you do purchase a Vention machine, your Vention machine will mimic what you see on screen over here exactly. So having it taught within the CAD will match your real life application. With this, I'm gonna have the Z-axis extend down. So I'll add another motion command, move to position. In this case, I do know what height I would like to move it to. So I'll have it set at 680 millimeters, confirm. And then once I'm actually down on top of the box, what I like to do is actually give it the gripper over here. So notice I do have a suction gripper over here to pick up the box. So with that, I'll add an extra command, and this is where I'll bring in the add weight. So essentially the add weight commands has your system wait for a specific action or event. In our case, we can have it set for wait for a set amount of time, a specific event, like I said, be it a completion of a motion or a digital input. For now, I'll stick with an amount of time and have it wait for 500 milliseconds or half a second, which should give it ample time to actually pick up a box. After that, I'll add 2 more motion commands to bring the z-axis up and over to the left. So add a motion, secondary motion as well. Bringing the z-axis up, I will do a move to position. In my case, again, I do know where I'd like to have it rest at, which is 875 millimeters. And then bring the x-axis, moving to a specific position. This one I'd like to teach, again, just to showcase how easy it is to actually do. So moving it over to the left, I can teach this new position. Again, if you realize it's slightly off and you need to change it, you can actually just drag it over again, press teach, and it will record that position. So again, just make sure I'm at the right position, teach. And then finally, I can drop the actuator back down with a z-axis, move to position, and I believe this is going down to 450 millimeters. With that, once I do get to the bottom, create another weight to allow it to drop off. Again, say 500 millimeters. And a final move command to bring it back up to the top. So z-axis, move to position, and bring it up to its cruising altitude of 875 millimeters. So as I run through this, you might have noticed there has been one extra option in the move commands, which is the add actuators button down here. So if I actually click on that, you'll notice that it does open up a larger window. So what this allows you to do is actually do a move combined action. So what that means is you can actually have multiple actuators move at the exact same time. In this case, for pick and place application, you might want to actually have one move at a time. So straight vertical, straight horizontal, vertical down. But in other applications, say you're looking to maybe accomplish a slight curve or have it run a little bit quicker, you can have it say the x-axis and the z-axis move at the exact same moment to complete a diagonal motion. In my case, I'll probably drop it back down to the single motion and bring back the 450 that I originally had. With this, I have essentially created my basic program for the pick and place and the move to home. So what I'll do is actually bring in one extra design that I've created just to make sure that everything does run smoothly. Let's close this over here. So while this loads, I'll be actually going into the final portion, which is the fourth portion, which is building and actually simulating the program. So what you saw me doing over there was essentially creating the individual actions or the functions within my program. And now I'll be going over to the main sequence and assembling the program itself. Again, you'll notice I've been doing all of this programming, or quote unquote programming, without writing a single line of code. So that's really what the purpose of MachineLogic has been designed for, to be as accessible to as many users as possible without any large coding background. And let's go over to the MachineLogic window over here, bring the design into view. So you'll see that I have it pre-configured as well with the x-axis, z-axis, belt conveyor, much in the same manner that I've shown earlier. Going over to the visual sequence, I'll run over the program that we just created. So we have the move to home, set system speed acceleration, and then the pick and place does have the positions, the weights, etc. So going back to the main sequence over here, we're actually going to build the program. So what I'll do is go to the add command icon and use a new command itself. So this is the add execution. So what add execution does is it allows you to call another child sequence within your program. Usually this is primarily used within the main sequence. However, if you do have a child sequence, you can call another child sequence within it. In my case, you do have, and from here, you have the option to choose how you would like to execute it. So you can choose to execute in parallel. So if you have multiple sequences created, you can have them run at the same time. Execute in series, which again, pretty self-explanatory, one after the other. And then the option to terminate or pause a selected sequence. In my case, I'll do it in series. And then from the dropdown, you actually, once you do have your child sequences built out, they will populate in the sequence name dropdown menu. In my case, I only have 2, so I only select home. And then from here, after my application is home, that'll be in the top left corner. What I like to do is actually get my conveyor system running. So like you saw earlier, you can actually add motion commands in your main sequence, but it's only recommended for smaller actions and not for the full program. In my case, I'd like to get it running, so I'll select the belt conveyor. And here you'll see one more extra option in the motion menu. So you'll see you have the ability to either start or stop a continuous move. Since conveyors do run continuously, I'll select this one. I'll leave it at the 100 millimeters per second speed and acceleration, but you can change it depending on your application. Again, I'll go to the add execution. So I've had my system is homed in the top left. I've started my conveyor up, and now I'd actually like to have the system go over to try to pick up the box. I'll do the pick and place application that I've built. And finally, once my program is finished, I'll do a final move command, which will stop the motion of my conveyor. So with that, I'll go over the program one last time to make sure that I have set it up correctly. So I have the move, begin motion of the conveyor, the secondary move or the secondary child sequence, and finally the actuator stop command for the conveyor itself. So on the left, I'll just collapse the menus over here to again make it a little bit easier to look at and press play to simulate. So if everything has been designed as correctly, the program will simulate on the right. Notice that it is a little bit jumpy at the beginning, simply as it is connecting to the simulation server, but it will run a little bit smoother. One thing to note, like I showed earlier, it is highlighting the action that it is being shown on screen right now. So with that, it does then go over to the right, pick up the box, move over to the left to drop it off again. So notice again, to say organize your system a little better, you do have the ability to collapse and expand your motions on the left. So I'll press play one more time to show that it is highlighting the individual actions as it runs through it. So again, homing the top left corner, begins the move of the conveyor, and then drops right away to the pick and place application. So moving to the position, gets there, waits, moves, and completes its actions over there.